Thanks to the organizer for providing these prompts like inspiration and also limits. So I like to be a little bit provocative and contrarian by offering that perhaps the future is not as limitless as we like to envision them to be. And to really start to justify this sentence, let's say, since several years, since about 2015, the prevalence of undernourished in the world has been steadily increasing. And actually, since 2014, the absolute number of people suffering from poverty and hunger has been increasing. And of course, COVID contributed to that, but the trend has been going on even before the onset of COVID. And now, in a somewhat post-COVID era, the trend is still continuing. And why is that? It basically comes down to the fact that the plants, which are the primary producers on this planet at the base of the food web, are suffering from high temperature and the drought. And agriculture, of course, are based on growing plants. So we have found, and not us, but our colleagues at Cornell, that drop in yield. And you can imagine, as heat waves intensify, it will only get worse. So we're looking at a future where a significant reduction in food availability will be a certainty. And the question is, how do we work within these limits? And it's not only the plants that are suffering. If we do a simple linear projection of past economic and the temperature data, we can see that well before 2050, we will have more or less surpassed the 2-degree line. And these temperature barriers have been found to be universally detrimental to all forms of life, including especially animals and also ecosystems. And the projection is really not good. And large-scale abrupt ecological collapse has already happened. And by the middle of the century, large parts of the world will be seeing these ecological collapse. And I think for humanity, it's not a really good news. So we really need to be operating within ecological and physiological limits. And the story, you might question how robust are these projections based on simple linear projection. And actually, they're in agreement with the newest publications in the community. So we did this just by simply using phenomenological empirical data, but complex climate models are essentially confirming our linear projections. And a very recent paper that's being reviewed from the great James Hansen essentially says even our curve is an underestimation of the trajectory because many different effects are not been taken into account, including feedbacks. And also, for some reason, I will tell you right now. So first take-home message is that the aerosols, essentially the pollution we put out while burning fossil fuel, has been masking at least 1 degree of additional locked-in warming. So to understand that, we have to do a mini lesson of notation. So the green arrow means A causes B, or an increasing A leads to an increasing B, and this inhibition sign means the inverse. So if you have a chain of causality where it's all green arrows, basically if A increases, then X would also increase. And if A decreases, X would decrease. If you have an odd number of these inhibitions, it's like multiply by -1, then you have the inverse behavior from the driver to the response. Otherwise, if you have an even number, then they cancel out. So it's similar to all green arrows. Reproductive success. Also, there's sometimes bisexual selection for things that are not practical, but still can give you reproductive advantage. Of course, we also have interaction from individual inventions through adaptation by a group. And that can increase the fitness of the group to survive, which also helps the individual to propagate its genes. And through accumulation of knowledge, heritage, that also makes it easier for individuals, like all the presenter here, to come up with new inventions which might be useful for the fitness and survival of the whole species. All right, let's come back to climate science. We all know that burning fossil fuel leads to greenhouse gases, which prevents heat from leaving the Earth. And when you don't have heat leaving, it causes warming. So because we have two of these, an odd number, burning fossil fuels causes global warming. But there's also a different pathway. Greenhouse gases are not the only thing that's in your emissions. you have sulfur dioxide, NOx emissions, and also unburnt volatile organic carbons. And these things form these visible smog nanoparticles, which can also promote the formation of clouds. And these things are bright. So what they do is that they prevent a part of the sunlight from reaching surface. So in a sense, they're like an umbrella keeping part of the sunlight away. And that has a cooling effect on the planet. So in summary, there's two mechanisms promoted by emissions. One is the long-term accumulation of a heating effect, and a rather short-term blocking of sunlight, which provides cooling. So it's not very straightforward. And we can also quantify these different heating and cooling contributions. And in reality, the amount of radiative forcing or heating power that's driving the current warming is the difference between the warming and cooling components. So in a renewable future, what would happen is we would actually lose the temporary cooling component, revealing a much larger net heating power, leading to potentially larger scale of warming at equilibrium. And one thing that we got out of COVID-19 was that we perturbed the relative magnitude of the heating and cooling component temporarily in a controlled fashion. So we can use that as a pseudo experiment to see how much that actually causes additional heating if we were to shut down the fossil fuel economy. So here's another diagram. So presumably, if you have less of these particles, you would have less generation of heat. So indeed, when you have a cleaner atmosphere, more light reaches the ground by a large margin as measured in this station in Netherlands. And more light reaching ground everywhere has led to an increase in ground soil temperature by a fraction to 1 degree Celsius, which is quite significant. And that happens over a few days to a week. And of course, the heat, the sensible heat rising air, is what's driving atmospheric circulations and transport moisture from the oceans. And that led to a record-breaking flood in China, which is absolutely outside of normal distribution, and which has been robustly attributed to the decrease in aerosols from reduction in burning. And very recently, even the fires in the US has been similarly attributed to the reduction in emissions. And that's not the whole story. There's another pathway, a chemical pathway, not the light scattering pathway. So the NOx emissions can also cause the generation of the cleaner radical in the atmosphere called the hydroxyl radicals. For those who understand chemistry, it doesn't seem very stable. It wants to become water. So this radical interacts with methane and basically oxidizes it. So in 2019 and 2020, we saw a rapid increase in the rise of methane. And the reason for that is when you decrease NOx emissions, you also reduce how much hydroxyl radical is available for destroying methane. So when you decrease the sink for methane, methane is able to increase faster. So it's really bad news indeed, right? So when we stop burning fossil fuel, in the short term at least, you have rapid heating due to losing aerosols and also increase in this greenhouse gas. So, but even if that's the case, it's very important to emphasize we must ramp down fossil fuel emissions because the temporary cooling benefit eventually will be overwhelmed by the slow accumulation of additional greenhouse gases. But we need to take this effect into account in addressing the future. And another fact, the cooling that's currently provided by pollution is not equally distributed around the globe. In regions that are manufacturing all the stuff that we consume, like in Asia, they will suffer the most rebound impact of heating. So it's not ethical for us to ask, say, China or India to decarbonize the developed world, including Chile. We should lead the way, in a sense, so that together we have a chance. Otherwise, they would essentially collapse. So we must brace for impact, and this year has provided some of the most dramatic pictures that we have seen. Reduction in water resources, leading to reduction in hydroelectricity, hampering the transition. There's a failing agriculture in multiple places in the world, including Italy, France, and of course, people are basically rendered unproductive by the heat in India, Pakistan, where it's like 50 degrees Celsius. So what do we do? So that's why I left academia temporarily to found a nonprofit called Mirrors for Earth's Energy Rebalancing. So we have turned down funding attempts from for-profit companies, including the likes of Siemens. And we want to keep everything we do, the data, the technology, open source. And we want to do so in a fashion that promotes global equity as we collectively face a dire future. So we have done some field experiments, including putting mirrors on the top of the apartment. And what we observe is that we can cool the roof temperature by up to 30 degrees Celsius, and also the interior temperature directly underneath the roof by up to 10 degrees Celsius. And that's dramatic if you think about the difference between 60 degrees and 40 degrees, in India. And even for well-insulated roof in this high-end apartment building in the US, we can still measure interior temperature drop of a couple of degrees, which can translate into electricity savings even for the developed world. So the other problem we're facing is water shortage. And for that, I think we have a rather convenient solution. So all the reservoirs used for fresh water and hydroelectricity were losing, just by evaporation, 300 cubic kilometers per year. And we're only overdrawing about 120 cubic kilometers per year from groundwater sources and underground sources. So if we can decrease the evaporative loss by, say, 50%, we can at least temporarily satisfy the availability of water. Of course, accessibility is not the same as availability, but availability is the first place to start. So we have done an experiment, floating mirrors at above water, on top of the surface water, even below water, to see how you can perturb the rate of evaporation. And based on the data, we can decrease evaporation rate by up to more than 60% at a 85% aerial coverage. And the most efficient method to prevent evaporation is to have the mirrors above water. And you see these high-frequency spikes. Those data are coming from this little friend coming for a drink, because we're measuring evaporation by weighing the bins, and they don't seem to be bothered by mirrors, so at least the impact on wildlife so far seems promising. And the temperature of the water also gets cooled significantly by up to 10 degrees Celsius. So you can imagine applying this in a different setting, say coral reefs, to cool ocean water down to prevent bleaching. So if we were to cover, say, 85% of the global freshwater reservoir using mirrors, we could more than solve for the current freshwater deficit. And in doing so, because we're transforming dark water into reflective surface, that portion of light is not absorbed by the Earth. And that cooling translates to fixing about 10% of the current greenhouse gas problem. But what about the remaining 90%? Well, there's another sector that can be exploited, which is agriculture. So we're currently developing methods to fabricate agricultural mirror arrays from exclusively materials that are going to landfills, like glass, plastic bottles, and also aluminum cans. So here is our latest prototype. So this prototype occupies a footprint of 200 meters squared. It has 70 meters squared of mirrored surface. And this area, averaged over the year, cancels the heating from 7 tons of CO2. So it's a very high leverage method. And the manufacturing emissions are more than offset by the embodied carbon, because we're making the supporting post from fast-growing bamboo, which is a wonderful species and building material for the future. And also, the cost for such a system is less than $100, even using off-the-shelf material. And we think that if cities or governments, local governments, wants to invest, the price can be dropped by a factor of 10. So cost-wise, in terms of thermal offsetting, it's by far the most efficient method to tackle with climate change, in addition to the water saving and agricultural benefits. And we have enough stuff going to landfills to make enough mirrors to compensate for 50 gigaton per year of emissions, which is more than what we're emitting. So it could have the potential to scale for global thermal mitigation. And we pretty much are confident that this method would work. For example, in Almeria in Spain, this area has been measured to have a relative drop in air temperature by more than 2 degrees Celsius, as the surrounding regions have been heating up due to global warming. So here is a very important point. Let's see how much we can have time to go into. That none of the other climate solutions you have heard of are going to be effective. And we want to justify that rigorously. So here is a list of some energy practices, a bunch of geoengineering, and what I call good luck methods. Like, let's disband the military. I think it would be very easy, the first priority on the government's agenda, right? So, and it's not easy, hard to see that it's really a wild south out there for climate mitigation and startups in the space. So, very surprisingly, there hasn't been a first principles analysis to really have an objective metric to compare these methods. Question of heat surplus. So there's more heat coming in than is escaping the Earth. And the quantity is about 1,000 terawatts, tera meaning 10 to the 12th. So in comparison, as much as we think we are such a wonderful and powerful species, our civilization only dissipates 18 terawatts of thermal power. In terms of electrical power, that's only 2 terawatts. So we are 1,000 times weaker than the climate monster we created out there. So what are the implications? The implications is that if we want to all be so altruistic and use all the energy we each use, which is 2 kilowatts, to fight global warming, whatever method you use has to have a minimum efficiency ratio of 100. But of course, from other fields, we know that economy really starts to go into recession whenever you have, you're using more than 10% of your GDP for energy extraction. So of course, tackling climate change is another overhead you have to deal with. So in the optimistic case, even if we were to accept a global recession and austerity, I don't think we can leverage more than 10% of our available energy to address global warming. So therefore, the efficiency must be increased by another factor of 10. So here is our basic metric, that for every joule of energy you put in to fix the problem, we have to be able to reject 1,000 joule out of the atmosphere into space. So as an example, an AC air conditioner can do with a ratio of 3, so which is 1,000 times too inefficient as a way to tackle global warming. And we have done this analysis for some very common methods, such as direct air capture, which the IPCC and the UN is calling for as our primary tool to use, but that's a factor of 10 too inefficient. And there's no way, based on fundamental thermodynamics, to scale that any better. So it's discarded. And the companies practicing or promoting this technique are essentially scams. Forgive me for using the word, but they're not really performing what they're claiming to do because of the intrinsic energy infeasibility. And what turns out is that the only feasible method is to really address the heat directly rather than to go through the greenhouse gas trapping part. And some of methods you might not have heard of. All right, so let's put some order in the Wild West. So of course, the 4 parameters are a little bit too numerous. We can't really visualize in 5 dimensions. So let's collapse the feasibility and the physics into one, called the physical feasibility and the efficiency and the sustainability for the future as the second axis, like so. So for example, planting trees is very popular because, of course, we want to have them for a sustainable future. Everything that we do is to be able to return our system to a prosperous state full of life. So, of course, it's really high on the sustainability axis. But we don't have enough area, land on Earth to do that. And the conversion of CO2 into trees doesn't really induce cooling because trees are much darker, say, than a desert. So sometimes in northern places such as the south of Chile, you actually induce warming by planting trees. Next, direct air capture we discussed. It's really bad. I don't know why people are able to convince politicians to support that. Maybe it's just our failing educational system, which other speakers have mentioned. And then we have a really abhorrent geoengineering method called stratospheric aerosol injections. So something people don't know is when you block light, unselectively, you also prevent light from reaching solar photovoltaics and solar concentrating energy capture. And you can lose up to 10% of energy efficiency. And that basically locks us into a more fossil fuel dependent future. So that's something to also consider. So here, the whole menagerie of different techniques, and I have color-coded them in ones in red, which are winning prizes, and which are getting funding. The ones in green, they are actually the best, but they are essentially economically, politically taboo. And the ones in blue, including our approach, surface-based mirrors, because we made it non-profit, there is no incentive to fund it within the current economy and the political structure. So coming back to inspiration and the mechanism of inspiration to promote human fitness, what's wrong? Obviously, the generation of novel ideas and techniques, that's functioning as intended. There's a menagerie of different approaches, but we have a problem selecting the right ones. And what's preventing the right selection is that the operating system is broken. Right? Everything is driven by short-termism and capitalism. When there's a carbon credit, everybody jumps on the bandwagon to try to exploit that. And that's certainly pushing us further and further down the abyss. So I will quickly go into some really idea. I'm amateur in this domain on how we can start to change that. I'm not a political scientist, and my knowledge comes from elementary school, attending the US, learning about the separation of power. But this theoretically wonderful design has been eroded because we have enabled the accumulation of power at the individual level and at the corporation level. So much so that some corporations are as powerful, if not more powerful, than states. And what they can do is basically hijack the system, rendering this mechanism ineffective and a slave to the individual dictates of these new feudal lords, in the language of Yanis Varoufakis. So now we have to consider that there's not only the means of production, but also means of opinion manipulation and behavior modification, according to this great thinker. All right, so basically, when you concentrate power in individuals, it leads to abuse. So how do we fix that? Well, we can start in a fashion that's similar to what we took on the engineering front by basically asking what properties in a future hypothetical civilization do we want? Probably most people can agree that we want equality of opportunity, and we want everybody to have at least a chance to access happiness through either material means or intellectual means, eudaimonic means, or a state of flow. And we want the system to operate based on the laws of physics. There's no around that. We are in a physical world. And we have to certainly operate within ecological limits, which we're overstepping by a factor of 10, roughly. So in the future, the currency will be energy. Something like Bitcoin would have negative value because they have wasted energy in their generation. And we have to outlaw inheritance of wealth. Everybody has to start on the same footing. And we have to consider how to provide this equality of opportunity in pursuing happiness. So let's start at this diagram. How do we separate the power again? So one way, I haven't consulted the president in making this slide. I hope he doesn't get offended. But I think people who have decision power, should have less access to financial power. And I think there's enough motivation for each of us, to pursue one of these and still be content. And I don't know how this mechanism would lead to what kind of subtle functioning, but perhaps we could start at smaller scale, maybe in Chile, maybe in some other Scandinavian countries. So with that, I'd like to thank the organizer and everybody that supported MIR, and all the people at MIR, and also at Roland Institute, where I initially had the funding to start this project.